Well, hello everybody, and welcome back to the Azure podcast. This is episode number 442. We're going to be talking about sort of IP services in general in Azure with our special guest Brian Lehr. And before we get to Brian, Sajid, it looks like we've got some news today. Actually, we've got lots of news. I don't know that we're going to get to all of it today for sure, because all the Ignite stuff hit
Right.
literally right before this. We're recording this episode on the 12th. But what do you want to highlight?
Yeah, and we should mention, Evan, that Ignite, as you said, starts today. Of course, by the time this episode is published, Ignite may be over, but we'll put a link to all of the recordings. Of course, everything in Ignite, you could come in and see it. So we'll definitely put a link to that. But I picked up a few that I thought were very interesting from today's announcements in Ignite. One of them is the Azure Resource Topology service. It's a new service that's being announced. And typically, we use Network Watcher that has a facility where it can create like a topology, but it's very limited to a specific region and also to a subscription. And obviously, applications today will span regions, span subscriptions, and you can't get that holistic view of the application. So this Azure Resource Topology now gives you that holistic view across regions, across subscriptions, at the same time letting you drill down all the way to look inside a subnet, right? So it gives you that nice all-up view as well as drilling down. So that's one feature that I thought was pretty neat. Another one which completely, took me by surprise is this new Cosmos DB innovation. So, Cosmos DB has always been seen as a NoSQL sort of database. Well, they have now started supporting relational databases as well. So imagine now this one database, the service supports both NoSQL as well as SQL style or relational style database access. And the way they've done it is to put, in the past they've had the MongoDB had, I think the Cassandra had, and other kind of
Well, there's a
protocol
T-SQL
adapters.
endpoint as
And,
well, which is relational at that point. Yeah.
Exactly, yeah, and now they've put PostgreSQL on top as well, right? So now using this one very highly available database service, you have a choice of how you want to access it. So that's another feature, another enhancement that came out today, and the third one, which I really liked, is virtual machine scale sets now support spot VMs, right? So you can imagine you create a VMSS,
Oh,
and
that
let's
is
say
nice.
as you scale it up, you say, hey, when we maybe I'll use a blend of normal VMs and spot VMs to save some money, because in case scales up to a large amount, I don't want to be hit with a gigantic bill. You could say, hey, help me with some of those costs by using spot VMs as you scale up, for example. So I thought that was really cool and innovative.
Yeah, no, that is it sort of gives you the ability to balance performance versus cost, right? With the flexibility.
Yep.
Yeah, no, that's great. Yeah, the couple that I wanted to highlight, and this sort of the first couple sort of show my world where things are always broken. But backup and restore updates for app services V2 and V3, right? So this allows you to actually back up the entire app, the configuration, because nobody ever deletes those or accidentally changes any of that, right? So that's a new capability. And then the other one, this is sort of on that same cost line, which I thought this was it's sort of a no-brainer feature. I know there's a ton of intelligence underneath it, but this is for Azure Backup. We have smart tiering for your backing it up to the archive tier, right? So you have these backups that are spanning over, let's say you've got it over 6 months, right? Your really old ones, maybe you just put them in archive, right? A cheaper storage mechanism, because you're not likely to go back to those versus 1 week, 2 weeks, a month. You want to pay for those to be sort of faster and more highly accessible, or faster accessible. Instead of having to manage that and think through that yourself, you can let the platform actually decide for you based on your historical use and what's in there and the like. And I mean, I as we sort of stepping back a little bit, we talk about things like that, things like the automatic indexing that are built into SQL Azure. Like, all these things take away some of the grunt work, really, of managing your services. Great to see these things show up capabilities wise. Just now you can focus on the business value, right, for your
Yes.
stuff. So,
Yep.
cool. Well, great. Well, no. So with that news roundup, let's transition over to Brian. Brian, if you could introduce yourself and let us know what it is you do here at Microsoft.
Sure. So my name is Brian Lehr. I've been with Microsoft for quite a while, actually. I was on the wide area network, the WAN side, for
Okay.
a good number of years. That just helped to ensure the bits get from point A to point B, and are traffic engineered in the best way. But in the last couple of years, I've been a product manager on the load balancer, NAT gateway, and public IP team, and my focus is the last one on that list, public IPs.
Okay, great. So what is let's when you and I first started talking about this, we were talking about there's a ton of capabilities that you can use in Azure around, IP addresses and public IPs. Let's sort of just start with the basic piece you referenced. A public IP, like, this seems simple, but there's a lot that goes around this at the end of the day.
There is, yeah. I mean, so public IPs, fundamentally internet protocol addresses, they're numerical labels. They serve as a way that you can route traffic to a specific point on the internet or within a private network. And as you said, it's a fundamental component of Azure networking. It's hard to really do much without IPs. They're used by pretty much anything you can think of across the board: virtual machines, load balancers, firewalls, network gateways, so on and so forth. Sometimes Azure will maintain the IP address for the customer, but a lot of times the customer just says, give me public IPs, and we actually give them a resource that sits in their subscription, like a public IP resource, and then they can attach it to whatever they want to. So we can go into lots of details about it, but yes, it is sort of a fundamental component. Without IPs, you really couldn't do any kind of Azure networking.
It's hard to connect if you don't have an endpoint, right? At
Yes.
that point.
Yes.
Yeah. So I have to. So Brian, I have to ask this question though. When it comes to IPs, we've all heard that the IP addresses that we have right now are a precious resource, right? And we're all supposed to use them as judiciously as we can. How close to the edge are we in terms of IPv4 addresses? Like I hear all sorts of mentions that we're going to run out any minute now and blah blah blah. And I always wonder, like, uh, when should I start hitting the panic button on that?
Well, I mean, how do I say this? For a company as large as Microsoft, we can pay for IPs, right? And we do pay for IPs. Like we have to pay quite a lot for IPs, right? So to put it in context, right, you're talking about IPv4s, right? So V4 addresses use 32-bit numbers, right? So there's 2 to the power of 32, a number of IPv4 addresses, give or take. There's some nuance there, but that's about 4 billion-ish, right? IPv6, which is kind of the new hip way of doing V6, doing IP addresses, uses 128-bit number, so it's 2 to the power of 128, and I'm not even going to try to say what that is. But yeah, V4 addresses are much more scarce, and they cost money because you have to go out in the auction block, quite frankly, and get those IPs. That's where we are. Just to answer your question, we're at the point where there are auctions for IP addresses, and you're paying, I won't say the amount, but you're paying quite a lot per IP address, much more than you were 10 or 15 years ago. So they are scarce, yes.
So sort of the follow up to that, IPv6, which for the life of me I still can't read or write them effectively personally. I suspect I'm probably not the only person with this problem. But Azure is, to varying degrees depending on the service and depending on the component. It is I can use IPv6, right? Is this something I should be looking at doing on a regular basis? Should this be my default config? What's your guidance there?
I would say, yeah, definitely start looking at what we call dual stack configurations, which have both V4 and V6 addresses on them. As you sort of intimated, our IPv6 story is a work in progress. So we're working across the board to enable it for all our services. So it essentially has parity with how we do for V4. Right now, as I mentioned, everything has to be in that dual stack configuration. So you also do have to have a V4 with a V6 address. One hurdle we just lowered for v6 is when it comes to public IPv4 and v6 addresses, they're now, as of, I want to say 2-3 months ago, absolutely free. So there's no cost associated with adding IPs, v6s to, for say, your VMs or your load balancers, which are both products that do support dual stack configurations with v6. So kind of lower the barrier to entry there. But yes, I would say start looking at that and seeing where you can integrate v6 into your deployments.
Do I need to tell my customers that I'm doing a V6, or will it just like will it just work for them? I mean, what's sort of the onus on me as an application or a workload developer if I say, hey, I want to get on board this IPv6 train, and beyond just checking the box somewhere that says, hey, use the dual stack. Do I need to tell somebody that I'm doing this, or?
Well, it sort of depends how if you want to direct customers to start using your v6 endpoints, you can. But
Okay.
the good thing about dual stack is that it's they exist together. They're in harmony. People can keep using v4, no problem. So in that sense, you don't have to. But yes, if you want to start directing people to use v6, then you can say, now we are v6 capable, right? It's an augment to what you have.
Yeah. Okay.
And Brian, what would be the incentive for our customers to say, okay, I'm going to use this v6 address, right, because it's available here? Is it kind of the same thing on their end? They also are going to be suffering in some way to get IPv4s, and is that the main kind of incentive here?
Yeah, I mean, there's multiple reasons why customers would want to move to v6. And as I said, everything is dual stack. So what you're doing right now is you're kind of setting the foundation for a move to what Azure will eventually support, which is v6 only deployments. But yeah, there are reasons. I mean, everybody is suffering from the same sort of v4 address scarcity across the board in all cloud services for all on-prem deployments. In some cases, we've heard from customers, state entities and so forth that have v6 requirements, like regulatory requirements that everything needs to move to v6 by a certain date. So there's a lot of reasons, but yes, it all has to do with that scarcity. And so what we're trying to enable here with dual stack is kind of you slow walk into it, you get used to having it coexist, and then eventually you can move to v6 only deployments.
So you talk about people have their IP address blocks, right, they own them, or they purchase them at non-trivial dollars at an auction, but so
Yes.
let's say I have my range. Do I have to use the range Microsoft gives me? Can I bring my own IP addresses to my deployments? Like, let's say I'm the classic one, maybe I've had some on-premises application, I've got some public IP endpoint that I want my customers, they've been going to with DNS for 20 years. I don't necessarily want to lose that when I move to Azure. Can I make that migration? Can I bring that with me?
I'm smiling because this is out of everything I've done this year, this is probably the one I'm most excited about. I'm very pumped about this. So in March of this year, we introduced the ability to bring your own public IP ranges to Azure. So as you mentioned, some customers will have IP ranges that they already own, from the market. They have it in their on-prem deployments, and for whatever reason, they don't want to just use the IP addresses that Azure gives them. And it could be that their IP ranges are what's called high reputation, so they're not put on spam lists. And they do a lot of egress from those IPs, so they need to make sure they don't get put on spam lists. Or potentially they have customers of their own that have allow listed those IPs in firewall somewhere, and they don't want to have to go around. And we were just talking about telling your customers moving to v6. It's worse to say, hey, we were this one set of v4 addresses, now we're another set of v4 addresses because we're in Azure, because that makes the cloud transition a lot harder for some customers. So it becomes a blocker for just actually coming to Azure in the first place. So yeah, now you can actually, say I have a /24, and it has to be a /24, which is 256 IPv4 addresses. It has to be at least that large, or the internet won't accept it. So this is primarily an enterprise feature. But you can create what's called a custom IP prefix resource with that range. We validate that you own it. You're authorizing us to advertise it, so the internet doesn't think that we're hijacking your range.
Right.
You go through a provisioning process, and then we hand those IPs to you, and you've got your /24 block, and you can use IPs from that block in much the same way you can as if we give you IPs. You can attach them to VMs, load balancers, and so on.
But I think the follow-up question would be one, like my Azure is going to only give these out to me, right? Because I brought them. Like it's not I'm handing my IPs
No.
over to Microsoft. Okay.
Yeah, they don't go to the general pool or anything like that.
Exactly.
No, they still belong to you. And I should say, just as I mentioned cost before, that does not cost anything for you to bring your IPs there, because we're not having to pay for them, right? You paid for the IPs; they still are owned by you.
We're just advertising. Yeah. Okay.
Right. And if anybody goes to check actually out on the database where you can see who owns such and such range, it will still say your name and your contact information, you being the customer.
Okay, great. And then the follow-up piece is it can, let's say I have this high value from an allow list perspective IP address. Is there downtime to move it from on-premises to Azure like that? Because if I've got a production app, I need to just, not that I can't take downtime, but I need to be cautious about doing this.
Right. So, I mean, there is, I would say, a migration process. So I mentioned
Okay.
that, okay, so you provision your range. I have my /24. I put it in the East US Azure region. Okay, I'm good to go. It's still being broadcast onto the internet from the old on-prem site, right? And so without getting into all the details of BGP, the Border Gateway Protocol, I'll just say that you don't want IP ranges to be broadcast the same range from multiple places at the same time, because we'll get very confused. So that the final step after you provision your range and you attach it to VMs and load balancers and firewalls and whatever you want the Azure infrastructure to look like, then you effectively hit a button, you run what's called a commission command, and that starts the process to advertise your range from Microsoft. And it actually goes out and starts talking to our routers, and our routers start broadcasting your range onto the internet. So at that point, yes, you would take a migration. You probably want to do it during a maintenance window on a weekend, low traffic period, and it would kind of slowly turn off on your end and turn on our end. Right. So there you try to make it as unimpactful as possible, but we're talking about BGP here, so you have to be a little bit careful.
It sounds a lot like sort of a DNS migration where conceptually it isn't super hard to do, but there is some time window as DNS is being sort of propagated out and BGP is being propagated out that you might have this inconsistent advertisement across the global internet at that point. Okay, so but again, not something to freak out about, but definitely something to be aware of.
Yep.
Okay.
So back on the deal stack that you were referring to earlier, Brian. So as I'm a software engineer, I build applications that run on Azure. I'm just trying to think like, what, if anything, I need to take into account in my application. Let's say, I am building an application, because I know sometimes there are apps that will read, the incoming IP address and, take some action on it or something like that. Is there anything that an application has to do to react to this deal stack?
That's a bigger question, I think, than IP addresses. I mean, yes and no, but I think it's going to be very application dependent. So I want to make sure I answer your question correctly, because individual addresses, yes, maybe I'm not able to understand your question in a way that I can answer it properly.
Like there are often applications that will look at the inbound IP address and make some kind of maybe some calculations or judgments on that, right? I'm just thinking about those kind. I know in the past I've written many applications where they'll inspect the inbound address. Maybe they use it for correlation or whatever, but there's some things that sometimes they will use it to generate maybe like a session ID or whatever it is that ties it to that incoming address, right? But now if that address is coming in through an IPv6 interface, right? Does that change the context in any way, or does that not really matter when it eventually hits the Azure application itself?
Again, I would say it's very application dependent. Obviously, the way that the headers and everything are arranged in the IP address are going to be different, so your application has to be aware of that. But everything that was in an IPv4 address that matters to the application should also be contained within a v6 address. So you can still get the same information out of there and direct it to a specific customer. Again, I'm sort of talking in generalities because it really is application by application dependent, but I would say you're definitely not missing any information. If anything, there's more information contained within a v6 address header that you can do more stuff with. I guess v6 specific, we've been talking about public IP addresses, and there is private, of course, as well. It's a little different when it comes to v6. They have something called global unicast addresses, which are kind of their equivalent of public, and then there's things called link local addresses and unique local addresses. So in that sense, there are some differences that aren't, it's not a complete one-for-one when it comes to v4 and v6. So I guess any application would need to be aware of that. But in general, I would hope that in most cases, it should work fundamentally the same way. Hopefully I answered that question. Okay.
I'm thinking
Thank
about
you.
this, Sajid. This actually, my gut response to that is, if you're writing an application that depends on a source IP for its behavior, IPv6 is going to make your life very interesting, because potentially every source user or device would have its own
Yeah.
IP. So maybe probably try not to do that would be the
Yeah.
answer.
I mean, as Brian was saying, we sometimes do inspect that inbound
Yeah.
header, right? The
Yeah.
HTTP header that contains the IP address, and then you
Yeah.
can say, oh, I don't know, use it for something or the other. And I was
Yeah.
just wondering, like, is there going to be a second header now? Saying, okay, here's the 2 IP addresses that that represent this user or whatever.
Yeah, I can think the email folks probably have thought this through, right? Because they use this, and like the proxy server folks have probably thought through this as well, because for them that source IP does matter, right? They could get a different behavior at that point. Yeah, I hadn't thought about that. Makes me glad I'm not on the application programming side of things. So the other interesting, and I can't remember if I heard this comment from one of the guests on the show, or in an internal conversation, but sort of switching gears a little bit. When you look at the Microsoft network, we're functionally a shadow internet now, right? It is the size and the scale of the internet. There is a big chunk of the overall internet traffic that is flowing sort of inside of our network, different sites here and there. The same is true for the other cloud providers, not saying we're necessarily different in that context. But how can I as a customer take advantage of that? Is there a way I can get my traffic to Microsoft sooner, or how do I manage that?
Well, actually, so talking about different flavors of IP, we have something called a routing preference that you can use with our standard SKU public IP. And most IPs by default are called routing preference Microsoft Global Network. That's a lot of words, but all it basically means is from a traffic engineering perspective, you're getting the best we can provide. And that means that I get to talk about this. There's something called hot potato and cold potato routing,
Yeah.
right?
Yeah.
So what we normally do in Microsoft is called cold potato routing, where our customers enter into our network on whatever edge site on our wide area network is closest to them, and then the traffic is carried across the series of tubes until our private internet effectively, until it gets to its destination, like an Azure region. And then the traffic egresses in much the same way through the wide area network and out in the edge closest to the customer. So we're trying to, by default, give you the best experience
Because
over
we
our
think we
network.
know our network best, right?
Right.
Better
And
than anybody else. Yeah.
exactly. And I mentioned at the top, like I used to be very involved with traffic engineering on the wide area network. And so we do the best we can to avoid congestion and get your packets to our region as best as we can, better than just the internet could do it,
Yeah.
right?
Yep.
But if you opt for an IP with routing preference internet, then we get to use the hot potato traffic engineering, where our network hands it off as quickly as possible. It doesn't want the potato. So in that case, the traffic would travel from the customer over the internet to the edge that is closest to the internal Microsoft destination. So again, to that, if they're trying to get to US East and they're starting in Singapore, it's going to go all the way over the internet until it gets to an edge that's basically next to US East, go into that region, and then we hot potato out. As soon as it's done whatever it needs to do, we toss the traffic back out to the internet, and then it goes all the way out of the internet to Singapore. And the reason you might want this is because the egress bandwidth costs are lower. And if you're sending terabits worth of traffic per month, having it cost less is nice if it's not latency sensitive.
So this is really about, I mean, I think it goes back to what I mentioned earlier. We think we know our network best, and we can sort of beat the least common denominator of the internet, which is sort of a whole bunch of ISPs, ourselves included, just sort of all saying, hey, we think this is a good path. Follow it. We say we know our network really well. We think we can optimize over that. But to your point, we're going to charge you a little bit for that sort of that intelligence. But if you don't care, just go to the default. So I think what I heard you say is the default is Microsoft Global Network. So that's the cold potato mechanism. So if you are, and so it sounds like if you're a customer who has lots of traffic, you ought to be thinking about potentially changing that, or at least evaluating that to see if that makes sense for you. But the average customer probably doesn't matter too much at the end of the day. Just use the defaults.
If you don't send that much traffic anyway, you're not getting charged to begin with, because there's a sort of a first tier we have where there's no charge, right? And then you have to kind of work up to it. So if you're sending terabits worth of traffic, then it's something you probably want to look into.
Okay. So what you just said is that cold potato is faster than hot potato. Is that what you just said?
Yes, because hot potato, we're tossing it.
I don't know.
We don't like it.
Go well with me.
Yeah. I didn't come up with the terms. I just like using them.
Yeah. I have been in some conversations where those come up, and it's always fun when you get to bring them up. No, this is great, Brian. I appreciate you coming on. We sort of talked about across a wide range of stuff. We talked about public IPs, IPv6, routing preferences. Anything we didn't hit that you want to leave the audience with?
Just one thing, and it's kind of a recent announcement. I think it really went out in the last couple of weeks. So we didn't talk too much about another different flavor of public IP addresses. When you get them from us, they can be either basic or standard SKU.
Oh, yeah.
And I'm biased, but standard's a lot more useful because it supports things like Azure availability zones. It's secure by default, so you have to have a network security group in order to access it. And it's also required if you want to use most of the modern networking products like Azure Firewall, like NAT Gateway, standard load balancer, all those types of things. You have to have what's called a standard SKU public IP address. The notification that went out in the past couple of weeks was that BASIC is actually on a depreciation path. No one needs to freak out because it's not being retired until close to the end of 2025. So you've got multiple years. But if you have questions about how to upgrade your infrastructure, feel free to ask us, and we'll try to help you. We have some good documentation out there, but we're adding to it and finding good migration paths for all the different resource types that might have IPs attached to them, because usually you don't have IPs just sitting around that aren't attached to things. They're being used.
And what was the rationale behind depreciating the BASIC? Is that people were just defaulting to the standard IP, or
we've seen more and more people move to standard, as I said, just because of the it's required functionality for a lot of the modern networking products, and a lot of the old BASIC stack is built on kind of, I'll say, legacy stuff on the back end, and we want to be able to better support the modern SKU that all the products use. So that's kind of the rationale behind it. But it's a long process. It's not happening tomorrow.
Yeah, short story, Sujit, is really the BASIC, and I forget what we called it. I think we just called it a public endpoint or a public IP previously, but the BASIC IP is the same thing we've had for years and years and years now. And I think to Brian's point, when we sort of re-architected that whole stack, the standard IP is coming out. I'm actually pretty sure, I think standard is the default when you go create one these days. So
it is default, yeah.
Yeah. So you generally shouldn't have to worry about it too much as a customer, it sounds like, but maybe if I've had some deployment that's been out there for years, I need to think about it.
And you can even do the migration from a classic IP, like a reserved VIP, all the way to the BASIC, and then all the way to a standard. So you can make quite a transition to go all the way to a modern SKU.
Yeah. Great. Awesome. No, that's a good call, because I had forgotten about that. That's actually, to your point, it's not something to run out and take care of today, but you should definitely be thinking about it if you've still got some basic ones, or even some classic ones out.
We're going to have to look at our Azure podcast endpoint. That was created on 9 years ago. So
we are
nice Azure podcast.
There.
I think we've talked about it on the show before, Judy. We are probably very much due some time spent on our infrastructure at some point. We have so much fun doing the show, and then this admin stuff of maintaining the site, right, just becomes low priority. Okay, great. No, awesome. Brian, thanks for coming on. I appreciate it. Fantastic conversation. Sajid, any last questions from you?
No, thanks, Brian. Is there anything in the Ignite that we're announcing that you haven't already talked about?
No, though I can say back on the bring your own IP topic that in the coming weeks we will have, I only mentioned v4 in our discussion, we're going to have the ability to do bring your own public IPv6 addresses as well. So that's something
Nice.
exciting that's coming. A little bit post-Ignite, but you can say that's coming soon.
Awesome.
Okay,
Thank
awesome,
you.
great. Thanks, y'all.